Hello students, you must have observed that in nature many things follow certain pattern, such as petals of a sunflower, holes of a honeycomb, the grains on a maize cob, the spirals of a pineapple, etc. Some patterns which occur in our day-to-day life also. For example, in our childhood, we used to construct pyramids with playing cards, in which the first row from the bottom contains n triangles, second row from the bottom contains n-1 triangles, third row from the bottom contains n-2 triangles, and so on. So, in all these examples, these all follow some specific pattern. Now, we'll see in this chapter some of these kind of pattern in which the succeeding term is obtained by adding, subtracting, multiplying or dividing the preceding term by a specific number. Usually these patterns are called sequences. So let us see what is a sequence. Now we define a sequence. Sequence when some numbers are arranged in a definite order, that is increasing or decreasing according to a definite rule is said to be a sequence. So what is a sequence? When some numbers are arranged in a definite order, that is increasing or decreasing according to a definite rule, is said to be a sequence. Now we'll see some examples. 1, 2, 3, 4, 5. In this list, each succeeding number is obtained by adding 1 to the preceding number. See, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. So clearly it is a sequence. See another example, 2, 4, 6, 8 and so on. In this, each succeeding number is obtained adding 2 to the previous number. That is 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8 and so on. So clearly it is also a sequence. If you observe both the sequence, the first sequence contains fixed number of terms, or I can say finite number of terms. So this is called finite sequence. Second sequence contains infinite number of terms. So it is known as infinite sequence. So again, sequences are two types. They are finite sequences and infinite sequences. In a sequence, each number, or I can say each position is known as a term. So now we'll see what is the term of a sequence. Term of a sequence. In a sequence, each number is known as term of a sequence. Term of a sequence. Usually, terms of a sequence denoted with denoted by A1, A2, A3 and so on AN, or T1, T2, T3 and so on Tn. You can denote it with A1, A2, A3 and so on, or T1, T2, T3 and so on. In A1, A2, A3, this subscript denotes position of a term. Position of a term, which means A1 means first term, A2 means second term, A3 means third term, AN means nth term. AN means nth term. Here AN is called nth term or general term. Here AN is called nth term or general term. If sequences follow a specific pattern, then those sequences are known as progressions. Now we will define a progression. Progressions. Sequences which follow a specific pattern are known as progressions. So what are progressions? Sequences which follow a specific pattern are known as progressions. Now we will see some examples. 2, 4, 6, 8 and so on. 2, 4, 8, 16, 32 and so on. 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6 and so on. If you observe these examples, the first one I can say plus kind of pattern, addition kind of pattern. The second one I can say multiplication kind of pattern, that is into kind. Third one I can say division kind of pattern, that is divided by. So based on the different patterns, again progressions are classified into three types. They are first one, arithmetic progressions, short form AP, geometric progression, short we can call GP, and third one harmonic progression, in short we can call HP. But in this chapter, we are going to learn about arithmetic progression. So our present chapter is arithmetic progression. Now we'll define arithmetic progression. Arithmetic progression. And arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term except the first term. Except the first term. And here the fixed number d is called common difference. Common difference. So what is an arithmetic progression? An arithmetic progression is a list of numbers. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term except the first term. The fixed number d is called common difference. The fixed number d is called common difference. So let us see some examples. And so on. 1, 2, 3, 4, 5 and so on. 10, 8, 6, 4, 2 and so on. 3, 3, 3, 3 and so on. If you observe these examples, in the first example, each term is obtained adding 1 to the preceding term. So I can say here CD is equals to 1. In the second example, each term is obtained adding minus 2 to the preceding term. That is CD equals to minus 2. Here CD equals to minus 2. In this, each term is obtained adding 0 to the preceding term. So here I can say CD equals to 0. By observing these examples, so we can conclude D may be positive number or negative number or 0. So the common difference D may be positive or negative or 0. Assume that A be the first term of an AP and D be the common difference of an AP. Common difference of an AP. Then first term A1 is equals to A. Second term A2 equals to A plus D. According to, so what is an AP? Adding, it's a list of numbers adding a fixed number D to the preceding number to obtain the next number. So A2 equals to A plus D, and third term A3 equals to A plus D plus D, that is A plus 2D, and so on. Nth term An equals to. Now we'll see here. So what is an AP? Adding a fixed number. This I can write like A plus 2 minus 1 into D. So second term 2 minus 1. 2 minus 1 is 1. 1 D is a D. So A plus D only. And third term I can write A plus 3 minus 1 into D. That is 3 minus 1 2. 2 into D 2D. A plus 2D. And if I observe, if I follow the same pattern, nth term will be A plus n minus 1 into D. A plus n minus 1 into D. So here An is called nth term. The nth term formula is A plus n minus 1 into D. Therefore the general form of an AP is A plus D, A plus 2D, A plus 3D, and so on, A plus n minus 1 into D. Here this is A1 first term, this is A2 second term, A3 third term, A4 fourth term, and so on. This is nth term. So general form of AP. So from this, the difference between any two consecutive terms is same. The difference between any two consecutive terms of an AP is same. That is what D. So D I can write A2 minus A1, which is equals to A3 minus A2, which is equals to, and so on, which is equals to An minus An minus 1. An minus An minus 1. So this is general form of an AP, and in that general form, nth term of an AP is A plus n minus 1 into D. So if you follow this, if you observe this nth term and general form, to form any AP, what are the basic requirements? Obviously, the basic requirements are A and D. So if you know the A value and D value, so we can form AP. So now we will see how to solve different problems using AP. Here the problem is, write first four terms of an AP when A equals to 10 and D equals to 10. So here given first term A equals to 10 and common difference D equals to 10, and using that information we have to find first four terms. We have to write first four terms of an AP. Given first term A equal to 10 and common difference D equal to 10. We have to find first four terms. So let the first four terms of an AP are A1, A2, A3 and A4. Using general form of AP, that is A plus D, A plus 2D, A plus 3D, and so on. So A1 equals to A, that is 10. A d equals to second term a plus d, that is 10 plus 10, 10 plus 10, 20. A3 equals to a plus 2d. A3 equals to a plus 2d, that is 10 plus 2 into 10, that is 10 plus 20, which is equals to 30. And A4 equals to a plus 3d, that is equals to 10 plus 3 into 10, which is equals to 10 plus 3 times 30, 10 plus 30, 40. Therefore, right here, therefore, first 4 terms of an AP are 10, 20, 30 and 40. So what is given? So we have to find first 4 terms of an AP when A equals to 10 and D equals to 10. So given first term A equal to 10 and common difference D equals to 10. So assume that let the first 4 terms of an AP are A1, A2, A3 and A4. And we knew general formula of an AP, that is A plus D, A plus 2D, A plus 3D and so on. So in this first term A1 equals to A, that is 10. Second term A2 means A plus D, that is 10 plus D is 10, 10 plus 10, 20. Third term 30, fourth term 40. Therefore first 4 terms of an AP are 10, 20, 30 and 40. Here the problem is check 4, 10, 16, 22 and so on is an AP or not. If it is in AP, if the sequence is in AP, find common difference D and write next 2 terms and next 2 terms. So here we have to find first whether it is in AP or not. If it is in AP, we have to find common difference and then next 2 terms and then next 2 terms. See, so here the given sequence is, that is 4, 10, 16, 22 and so on. Since let us assume that this is A1, A2, A3, A4 and so on. Since we know in AP, if it is in AP, the common difference will be equal between the consecutive terms. That is A2 minus A1 should be equal to A3 minus A2 should be equal to A4 minus A3. A4 minus A3. Therefore, let us find D equals to A2 minus A1, which is equals to A3 minus A2, which is equals to A4 minus A3. That is 10 minus 4 equals to 16 minus 10 equals to 22 minus 16. That is 6, 6, 6. So the common difference here is same, equal. Therefore, the given sequence is in AP. The given sequence is in AP with common difference D equals to 6. With common difference D equals to 6. Now, next 2 terms. Now, next 2 terms are A5 and A6. A5 and A6. By the general formula, A5 equals to A plus 4D. That is, what is A there? 4. 4 plus 4 into what is D there? 6. that is 4 plus 4 6 are 24, that is 28. Then A6, that is A5 plus D, 28 plus 6, that is 34. Therefore, the next two terms are 28 and 34.